Hi students, friends, good afternoon to all. I welcome you all in this fluid mechanics lecture. Now we are going to start with the last unit as per our sequence. The last unit is unit number 4, notches, weirs and spillways. So this unit today, now we are going to start here. So these are the contents, syllabus content of this unit. It has been divided into groups, Group A and Group B. In Group A, we have the contents like types of the notches, derivation of discharge equation for the rectangular notch, triangular notch, trapezoidal notches, then velocity due to approach, then Francis formula, calibration of notch, and errors in the measurement. These are the contents of the Group A. Group B, we have the weirs and spillways, sharp crested weir, then broad crested weirs, calibration of the weirs, time required to empty the tank with the notches and weirs, profile of OG spillways, types of the nappe, and ventilation of weir. So these are the contents that we are going to study in this unit number 4. Okay. So here now we are going to enter into this contents directly. Before that, I will tell you the assignment questions. You note down. Okay, only 4-5 questions I will tell you, and this will be your last assignment. You can give the assignment number 8. Write the questions there. Question number 1. Define following terms. Define following terms. First, notch. First term is notch. Second term is weir. Notch, weir. Then nappe. Then crest. You can give the notation like A, B, C, D. Notch, weir, nappe, crest. This is question number 1. Question number 2. Derive an expression. Derive an expression for discharge over rectangular notch. Rectangular notch or sharp crested weir. Rectangular notch or sharp crested weir. Question number 3. Derive an expression for discharge over triangular notch. Instead of rectangular here, triangular. Okay, question number 4. Explain the term velocity of approach. Velocity of approach. And last question. Last question. Give the classification of notches and weirs. give the classification of notches and weirs. Only 5 questions are there, very small questions. Answers are there for these questions. You can complete it within an hour. एका तासामध्ये assignment complete होईल. So now let us see the actual content of this unit. What is notch? Can anybody tell the answer for this question? Define notch or what is notch? कोण सांगेल का? Notch कशाला म्हणायचं? In unit number 3, fluid kinematics and fluid dynamics, there we have studied orifice. Right? So what is an orifice? Small opening in the side of
the measuring device.
Yes, repeat once again.
It is the flow measuring device. The small opening is provided at the bottom of tank. Okay. So orifice is the device. So here we have to, we should not forget to mention that it has the closed perimeter. Okay. Or periphery. Orifice जो असतो तो कसा असतो? हा क्लोज ते ओपनिंग जे आहे ते ओपनिंग इज क्लोज पेरिमीटर. It is having closed perimeter or periphery. Okay. And it is the opening, small opening provided in the side of the tank. Tankच्या साइडला किंवा at the bottom of tank. Okay. Having closed perimeter, close circumference or perimeter we can say. So that device is called as the orifice. Now this orifice is used for measurement of the discharge. Similarly, notch also can be, if you see the definition here, it is an opening provided in the side of the tank such that, now here again this is also opening provided in the side of the tank. मग या दोन्हीमध्ये काय फरक आहे? Notch and weir मध्ये. So that difference we should understand, we should know. Okay, such that now difference is here. Liquid surface in the tank is below the top edge of an opening. Okay, जो weir चा top edge आहे, let us say, now here I need to clean it. Let us say this is the weir, rectangular type of weir provided in the tank. Okay, on the side of the tank. Here, the liquid surface in the tank is below the top edge. हा जो top edge आहे, याच्या खाली हे liquid surface या ठिकाणी असली पाहिजे. And opening म्हटलेला आहे या ठिकाणी. Okay, top edge of an opening. This perimeter here, it is not closed in case of notches. Okay, notchच्या केसमध्ये हे जे ओपनिंग आहे ते ओपनिंग असं वरून क्लोज नाहीये. Are you getting my point? In case of orifice, that opening is closed. असं क्लोज होते. तेव्हाच आपण त्याला काय म्हणतो? Orifice. But in case of notch, this is not the condition, and water level is here, below the top edge of the opening. This is the top edge. याच्या खाली हे पाण्याची लेवल या ठिकाणी पाहिजे. So that we can have the measurement also here. Okay. And these notches, they can be provided in the small open channel. जे open channel असतात छोटे आकाराचे लॅबोरेटरी मध्ये वगैरे, त्या स्मॉल ओपन चॅनलला पण त्या ठिकाणी हे नॉचेस हे प्रोव्हाइड केलेले असतात. बेसिक पर्पजेस फॉर मेजरमेंट ऑफ द डिस्चार्ज. ओके, this is also used for measurement of discharge, and orifice are also used for measurement of the discharge through the tank. Orifice are particularly used for the tanks. Notches can be used for tank as well as for the open channels. Okay, and this notches, they are generally made up of the metallic plate. Okay, thin metallic plate पासून हे बनलेले असतात. Notches are made of the metallic plates. Okay, now then what is weir? Weir म्हणजे काय? You might have studied in the diploma. WEIRS spillways, KT weir you might have studied.
What is the KT weir? काय म्हणतो आपण याला? लॉंग फॉर्म काय KT weirचं?
कोल्हापूर काय तर आहे.
कोल्हापूर. Yes, Ketan.
ते तर माहित नाही सर. कोल्हापूर.
See, this is KT means Kolhapur type.
कोल्हापूर टाइप वेयर.
Okay, this is Kolhapur type Bandara, Kolhapur type weir. As it was successfully implemented, used, constructed in the Kolhapur region, so it has been given the name Kolhapur type Bandara or Kolhapur type weir. What is the function of weir? Weir चं काय फंक्शन असतं?
पाणी स्टोरेज करण्यासाठी सर.
Correct. To store the water on the upstream side. Okay, एखाद्या रिव्हर वरती किंवा ओढ्यावरती आपण this weir is nothing but it is the masonry structure. It may be made up of the stone masonry, brick masonry, concrete, anything. Okay, the purpose of this weir, this masonry, is to store the water on upstream side of the weir. Weir च्या upstream side ला पाणी त्या ठिकाणी स्टोर करणे हा त्याचा बेसिक पर्पज आहे. And excess water can be flown over the weir. Excess water जे आहे ते weir वरून या ठिकाणी फ्लो होऊ शकतं. So that is the weir. But in addition to this storing water, weir can be used for, it can be used as a discharge measuring device. Okay, त्याचा आपण discharge measuring साठी पण वापर करू शकतो. Okay, how we can use it? So weir and notches are nearly somewhat similar, and that we will see now in the classification. What are the various types of weirs and notches? Right. And what is spillway? Spillway again, it is nothing but it is the type of weir only. It is a safety wall provided in the dam so that excess water can be overflow over the spillway. Okay. या spillway वरून excess पाणी जे डॅम मधलं ते त्या ठिकाणी बाहेर पडू शकतं. So that is spillway. So that also we will see afterwards in details. So let us read the definition here. Notch may be defined as opening provided in the side of the tank such that liquid surface in the tank is below the top edge of an opening. Notches are made up of the metallic plates, are provided with the narrow channels. Okay, they can be provided in the narrow channels, particularly in the laboratory channels, in order to measure the rate of flow of the liquid. त्यासाठी वापरलं जातं to measure the discharge or rate of flow. Okay, in general, notches are used for measuring the flow rate of the liquid from the tank or in a channel. Right, so that is the use of notches. Then weir. So how we can define the weir? It is the name given to a concrete or masonry structure built across a river or stream in order to raise the level of water on the upstream side and to allow the excess water to flow over its entire length to the downstream side. Okay. So this was the definition of the weir. And what is nappe or vein? See, when the notch is provided here like this, and water is flowing here on the upstream side, from the upstream side, when the water falls below here from the notch or weir, whatever the sheet of water is forming here, this sheet of water, it is called as nappe. Okay, it is called as the nappe or vein. Okay, the sheet of water flowing through a notch or weir is known as nappe. French term meaning sheet of water, that is nappe. Next term is the crest or sill. So what is the meaning of crest? We'll tell. Crest कशाला म्हणायचं? Yes.
Top
It is
portion
clear.
of
Yes.
weir or dam.
Correct. The topmost portion of the notch or weir is called as the crest of the weir or notch. Okay. So here you can see, if you want to show here in the through the diagram, we can show. Let us say this is the rectangular notch or weir. Then this portion is called as the crest of the weir, okay, or crest of the notch, right? In case of spillway, this portion is called as the crest, त्याच्यावरून पाणी हे फ्लो होतं. Okay, the bottom edge of notch's bottom edge or top of the weir over which water flows is known as a sill or crest. जर नॉच असेल तर त्या केस मध्ये आपण काय म्हणणार, we call it as a bottom edge. Okay, this is the top edge, this is the bottom edge. Okay, and in case of weir we call it as a top of the weir, okay, over which water flows is known as sill or crest, and its height above the bottom of tank or channel is known as crest height. Suppose this is the channel bottom. The channel bottom पासून ही जी height आहे, this is called as the crest height. Okay, this rise, this h is called as the crest height. So this was about these terms: notches, weirs, nappe, and crest. Now we'll see the classification of notches and weir. There are various ways to classify the notches and weir. So we can classify, we will see the classification of notch first, and then we will see the classification of weir. Notches can be classified according to the shape of the opening. How the opening has the shape, what kind of shape it is having. Depending on it, we have the different types of notches. Like first one, rectangular notch, triangular notch, trapezoidal notch, and staped notch. Okay, so what is the meaning of rectangular notch? The notch having a rectangular shape like this, it will be called as a rectangular notch. Okay, then triangular, okay, then trapezoidal, okay, and then staped notch. Staped notch means rectangular notch only, but it is the combination of different types of rectangular notches like this. The formation of step is here. Okay, so this type of notch is called as the staped notch. Okay, so this was the classification based on the opening. Second, according to the effect of sides on the nappe. Effect of sides. तो जो नॉच आहे त्याचा नॉचचा जो साइड आहे त्याचा त्याच्यावरती इफेक्ट काय होतो, कशावरती, ऑन द नॅपे जे पडणारे पाण्याचं शीट आहे त्याच्यावरती काय इफेक्ट होतो, त्याच्यावरून याचं परत क्लासिफिकेशन आहे. नॉच विथ एंड कॉन्ट्रॅक्शन. ओके, सेकंड वन इज नॉच विदाउट एंड कॉन्ट्रॅक्शन. ओके, किंवा त्याला दुसरं नाव आहे सप्रेस्ड नॉच. ओके, लेट अस से if this is the channel of water, okay, open channel, आणि या ठिकाणी जो नॉच आहे त्याला असं हेच नाहीये. जर अशा टाइपचा असेल नॉच, ओके, दिस इज कॉल्ड एज द कॉन्ट्रॅक्शन. नॉच विथ द कॉन्ट्रॅक्शन, आणि इथून पाणी पडतंय आतमध्ये. ठीक आहे, सो सच काइंड ऑफ नॉच इज कॉल्ड एज द नॉच विथ द एंड कॉन्ट्रॅक्शन. आणि हा पोर्शनच नसेल, फक्त त्या ठिकाणी असं असेल पोर्शन आणि पाणी वरून वाहतंय, then it is called as the notch without end contraction or suppressed notch. Okay, so these are the two types of the notch. I think from this diagram you may not be able to understand it clearly. What is the end contraction, notch with end contraction and suppression notch? So I think I should show you the diagram of it. Yes, why? Practical number. List of practical numbers. Broad and sharp cluster weir, practical number 7. So here in this diagram, you can see the weir or notch with the end contraction. Okay, it may be visible to you clearly. Diagram you can see there. So the first diagram here, it is having weir with the end contraction. This is the end contraction here. Okay, contracted weir or rectangular notch here. Suppressed or without end contraction, या ठिकाणी contractionच नाहीये. So this is the classification of notch and weir. हे दोन्ही मध्ये आहे, notch मध्ये पण असतं आणि weir मध्ये पण असतं. We were here, right? So, you can note it down in your notebook. हे डेफिनेशन सगळ्या नकोत लिहायला, फक्त क्लासिफिकेशन तरी लिहा किंवा टायटल लिहा आधी. नॉच जे आपण डेफिनेशन पाहिलेत, नॉच, weir, then nappe, crest, and then title लिहा classification of notches and weirs. Classification of notches and weir, right down there. According to the shape of opening, rectangular, triangular, trapezoidal, stepped. Suggestions वगैरह. Right on the second classification, according to the effect of sides on the nappe, notch with end contraction, notch without end contraction, or suppressed notch. Is it over? Now classification of weir, we are going to see here. Write down the classification of weirs. First, according to the shape of crust. Crustचा shape जो आहे त्याच्यावरून. नाही, एक मिनिट वरती त्याच्या राहिलेला आहे. According to the shape of the opening. According to the shape of the opening. Rectangular, triangular, trapezoidal. Rectangular, triangular, trapezoidal, right? Next, according to the shape of crust, thin plate or sharp edged weir, narrow crested weir, broad crested weir, and ogee weir. These are the classification of the weirs based upon the shape of the crust. Next, according to the effect of sides on the emerging napping. Sides जर असतील तर weir with end contraction, नसतील तर weir without end contraction. जर end contraction त्या ठिकाणी असेल तर काय होईल त्या ठिकाणी emerging जो nappe आहे it will have the narrow width. जर विदाउट एंड कॉन्ट्रॅक्शन असेल, साइडने त्या ठिकाणी कॉन्ट्रॅक्शन नसेल तर ते पूर्णपणे पाणी जे शीट जे ते भरून त्या ठिकाणी वाहेल. सो इन सच केस व्हेंटिलेशन इज रिक्वायर्ड. weir without end contraction. Is it over? Then let us see now the next point, that is flow or discharge over a rectangular sharp crested weir or rectangular notch. या दोन्हीसाठीचा इक्वेशन किंवा डिस्चार्जचा फॉर्म्युला सेम आहे. कशासाठी? शार्प क्रेस्टेड weir, rectangular sharp crested weir किंवा rectangular notch. Now here we are going to see the derivation for this rectangular notch. Okay. For this purpose, we have to see this diagram here. This is the rectangular notch or weir. Capital H is the total depth of water over the crest, right? In this particular rectangular notch or weir, we have considered a small strip of water. जी sheet आहे हे छोटी आपण strip या ठिकाणी consider केली. At a depth of here, the distance between this here between इथपर्यंत जे depth आहे ते h आहे. And the width depth of this weir this strip, it is DH. Okay. In area of strip, I will L is the total length. The area of strip will be L into DH, right? What will be the rate of flow? What will be the velocity of flow here? Velocity will be theoretical velocity of water through the strip will be under root of 2gh. Right. Then what will be the discharge? Discharge equation, we know that discharge is nothing but velocity into cross section area. So what is the cross section area of strip? Strip मतलब discharge अपन करते हैं. Theoretical discharge through the strip. Right. Area of the strip multiplied by theoretical velocity. Right. What is area of strip? Length into height of the strip, that is dh. What is velocity of flow? Under root of 2gh. Right. This is the theoretical velocity or discharge for flow through the strip only. If I want to find out what is the total discharge, theoretical discharge between this crest of the weir to the top level of water, in that case, we have to do the integration of this equation. Equations आपल्याला काय करावं लागेल? Integration करावं लागेल. Okay. So I have written this equation like this. Between the limit what? Between the limit 0 to capital H. Okay. So now here I will take the constant things outside here of the integration and integration च्या आतमध्ये under root of h फक्त राहिलं, under root of h dh किंवा h raised to 1/2 into dh हा पार्ट राहिला या ठिकाणी. Then now let us do the integration of h raised to 1/2. कोण सांगेल? What is general formula? कोण सांगेल?
n into x raised to n plus 1 divided by n plus 1.
X raised to n plus 1 divided by n plus 1. This is the integration of this x raised to n. Now here the power of h is 1/2 plus 1 divided by 1/2 plus 1 that we have to do. So 1/2 plus 1 is equal to 3/2. Okay. So this part will be as it is L into under root of 2g in bracket h raised to 3/2 divided by 3/2 bracket complete 0 to capital H. Now if I put this here values here, I will get here this z L into under root of G into 2 by 3 into h raised to 3 by 2. Okay. If I write this is a theoretical discharge properly, I can write here 2 by 3 into L into under root of 2 into h raised to 3 by. जर या ठिकाणी आपल्याला ऍक्च्युअल डिस्चार्ज पाहिजे असेल तर सीव्ही मल्टिप्लाय करा. Okay, this is the derivation part of this equation. Like this. Okay, so write down this final formula for the Q theoretical and Q actual. Is it over?
Yes, sir.
Yes, you can write h raised to 1.5. Okay, 3 by 2 च्या ऐवजी तुम्ही 1.5 पण लिहू शकताय, no problem. Anisha. Now
Yes.
see the derivation of discharge over triangular notch or weir. Okay, write on the title. Discharge over triangular notch or weir. Discharge is derivation is same here. Somewhat difference is there. Let us say this is the triangular notch having angle theta, and this is the strip of water which has shown here. The depth of water is from up to here. Okay, this is the strip of water. Now, if I take the half of the triangle here, this portion, then I will draw it. It will be, I can draw it like this. Okay, here you can see the angle theta is divided by 2. That is theta by 2. Okay, and here tell me what is tan theta? Tan theta by 2 here. Opposite side divided by adjacent. कोण सांगेल? Yes, this triangular notch is also called as V notch. Okay, you can see here we have written here V notch. What is tan theta here? AC, opposite side, divided by this capital H minus small h. Okay, I can write here tan theta by 2 is equal to AC by h minus h. AC is equal to capital H small h into tan of theta by 2. Okay, this was about this much portion. Total mal length पाहिजे असेल तर it is twice, so I can write here 2 times h minus h into tan theta by 2. Okay, this is the length. What is height? dh. So I will get the area of strip dA is equal to 2 into h minus h into tan theta by 2 into dh. Okay, this was the small area. Then what will be the theoretical discharge? What is the velocity through this at this strip here? It will be theoretical discharge. Velocity will be under root of 2gh. Right? Then I can write dq, discharge, theoretical discharge through the strip is equal to L into h minus small h tan theta by 2 into under root of 2gh dh. Right? Now this is the discharge through the strip. I want an entire discharge through the strip or this notch. So I will apply the limit between 0 to capital H and do the integration of this equation. Okay. Here you can see discharge through the strip dq, total discharge capital Q is equal to integration between the limit 0 to h and this term. Now those things which are constant that can be taken outside the integration sign, and we have taken these things out of the integration sign. What are that? 2 tan theta by 2 into 1 root of 2gh, 1 root of 2g. Integration between the limit 0 to h, capital H minus small h into h raised to 1/2 into dh. Okay, this is the integration here. हा जो अंडर रूट ऑफ 2gh आहे तो h जो आहे अंडर रूट ऑफ h हा आपण असा लिहिला. आता मी काय करतो, हा पार्ट ॲज इट इज ठेवतो आणि हा जो आहे h रेस्ट टू 1/2 त्याने याला मल्टिप्लाय करतो आणि याला पण मल्टिप्लाय करतो. मग मला काय भेटेल या ठिकाणी कॅपिटल H स्मॉल h रेस्ट टू 1/2 मायनस स्मॉल h रेस्ट टू 3/2. ओके, त्याची पॉवर आहे 1. 1 plus 1/2 it will be 3/2. So here I got 3/2. Now I will do the integration of this equation. The parts integration करें. Then what I will get? Formula क्या है? Y is equal to x raised to n. Then x raised to n plus 1 upon x raised to n plus 1. This is the formula. So I will do the addition of 1 here. This one. Okay, you can see here the integration. File. The capital H आहे, capital H आहे, constant आहे. ते तसंच राहील. h raised to 1/2 जे आहे त्याचं इंटिग्रेशन, याचं इंटिग्रेशन काय आहे? h raised to 3/2 divided by 3/2. त्याचे इंटिग्रेशन काय येईल h raised to 5/2 divided by 5/2 between the limit 0 to capital H. Okay. Now I will put the value of this capital H inside this small h here, and I will get here like this. Okay. Base सेम करण्यासाठी मी या ठिकाणी मल्टिप्लाय केलं 5 ने. ओके. सो हे 2 आहे ते आउटसाइडला जाईल इकडे 15 या ठिकाणी आलं 4/15 h raised to 5/2. Okay, energy addition to power. I will get here. Now this 4 multiplied by this say 2, it will be 8 by 15. Okay, tan theta by 2 this part into under root of 2g and h raised to 5/2. This is the equation for the theoretical discharge. Okay. Here you can see. And the final equation we got here, Q theoretical is equal to 8 by 15 tan theta by 2 into under root of 2g into h raised to 5/2. We know that Q actual is equal to CD into Q theoretical. Okay, if I multiply the above equation by CD, then I will get the actual discharge. So Q actual is equal to 8 by 15 CD into tan theta by 2 into under root of 2g into h raised to 5/2. Okay. जर त्या ठिकाणी थीटाची व्हॅल्यू 90 डिग्री असेल, CD is equal to 0.6 असेल, tan theta काय होईल त्या ठिकाणी जर थीटा इक्वल टू 90 डिग्री असेल तर tan theta by 2 will tan 45. Tan 45 is equal to 1. Okay, and therefore we can write this equation as Q is equal to 1.417 h raised to 3/5/2. So you can note down these equations here in your notebook. Write down this equation for the theoretical discharge, then write down this. Do it fast. Next, write down the title. Advantages of triangular notch or weir over rectangular notch or weir. Advantages of triangular notch or weir. ट्रायंग्युलर नॉचचे रेक्टँग्युलर नॉचच्या वरती काय ऍडव्हांटेज आहे त्याच्यापेक्षा? So first advantage is that expression for the discharge for the right angled V notch is very simple. जर आपण वरती पाहिलं तर आता हे बघा एक्सप्रेशन, याच्यामध्ये काय फक्त एच फाइंड आउट करायचं आपल्याला. किती सिंपल एक्सप्रेशन आहे. फॉर मेजरिंग द लोड चार्ज ट्रायंग्युलर नॉच वर नॉच गिव्स मोर ॲक्युरेट रिझल्ट्स दॅन द रेक्टँग्युलर नॉच. जसं वियर आपल्याच्यामध्ये मॅनोमीटर्स मध्ये डिफरन्शियल मॅनोमीटर्स मध्ये आपण पाहिलं की जर मोर ॲक्युरेट रिझल्ट पाहिजे असेल देन वी शुड प्रेफर द इन्व्हर्टेड डिफरन्शियल मॅनोमीटर. इट इज मोर सेन्सिटिव्ह. सिमिलरली हियर ऑल्सो छोट्या डिस्चार्जचा जर त्या ठिकाणी फ्लो असेल, व्हॅरी होत असेल, then to get the accurate result we should prefer the triangular notch or V notch. In case of triangular notch only one reading is required for the computation of discharge. जर आपण वरती पाहिला फॉर्म्युला तर त्याच्यामध्ये फक्त आपल्याला h फाइंड आउट करायचं. Okay, and directly putting that value in this equation you will get the answer to the problem. Okay, note it down these three advantages. आणि फोर्थ आहे चौथा, व्हेंटिलेशन ऑफ द ट्रायंग्युलर नॉच इज नॉट रिक्वायर्ड. व्हेंटिलेशन जे ह्याच्यामध्ये करणं गरजेचं पडतं. सप्रेस्ड ऑर वियर विदाउट एंड कॉन्ट्रॅक्शन जे आहेत त्यामध्ये व्हेंटिलेशन करावं लागतं. रेक्टँग्युलर ट्रायंग्युलर असेल तर करायची गरज पडत नाही. ओके, नोट इट डाऊन फास्ट. I have taken your attendance. You can leave the session now. If anyone has query, you can ask me. And you have the test now, so I will send your test paper, question paper on your group. So I have sent the question paper on your group. Now you can start writing the exam. Okay. So let us stop here now. I will close the session. Thank you all of you.